Hello dear friends, good morning. Welcome to Benzakademi. In this video, we are going to discuss about the very important topic in organic chemistry, that is isomerism in organic chemistry. Isomerism is a very important field which deals with the structures, physical properties and chemical properties of most of the organic compounds. So what is isomerism? So it is a phenomenon, isomerism is a phenomenon where different molecules with different physical properties and chemical properties with the same molecular formula. So this word is very important, same molecular formula. So isomers are the molecules having same molecular formula, but they have different physical properties and chemical properties. Isomerism is classified into two types. First one is structural isomerism and second one is stereoisomerism. So we have two types of isomerism. One is based on the structure, another one is based on the orientation of the groups present in the molecule. So what is meant by structural isomerism? So structural isomers, they are all the molecules, they have the same molecular formula, but they have different structures. So because of their different structures, they have different physical and chemical properties. The structural isomers are also called as constitutional isomers. They differ in the way of bonding, that means the connection pattern or connection sequence. Atoms present in these molecules are connected differently. The structural isomerism is classified into four important types. Number one is chain isomerism, number two is positional isomerism, number three is functional isomerism, number four is metamerism. So what does mean by chain isomerism? So these are also the molecules having same molecular formula, but they have different chain length. So they have different chain length, but having same molecular formula. So example. So we are given with two examples. Number one is isobutane and number two is N-butane. So in the case of N-butane, we have a long straight chain hydrocarbon, that is N-butane. N represents it is a long unbranched chain, and then in this case this is also a butane molecule with 4 carbon atoms, but the chain length is 1, 2, 3 and it has one branching, so it has different structure. Next type is positional isomerism. These are the molecules having same molecular formula as usual, but the functional groups are located at different positions. So this word is very important. The functional groups are located at different positions. So examples. We have two examples, one is 1 butanol and another one is 2 butanol. So OL, that means alcohol functional group. So we have two alcohol molecules, both are having same molecular formula. So in the first case, the 1 butanol, where the OH group is attached to the first carbon atom of the molecule, whereas in the second case the OH group is attached to the second carbon atom of the chain. So these two molecules having same molecular formula, same functional group, but the only difference is the position. So that's why these molecules are called as positional isomers. Next type of isomerism is functional isomers. So these are also molecules having same molecular formula, but the only difference is the function groups. So each molecule having different function group. So we have two molecules. This is 1-butanol and this is butanol. So butanol having alcohol functional group, or butanol having CHO functional group, that is aldehyde functional group. So both the molecules having same molecular formula, they have 1, 2, 3, 4 carbon atoms, 1 oxygen atom. Similarly here also we have 1, 2, 3, 4 carbon atoms with 1 oxygen atom. So they have same molecular formula, but the functional group is different. The first case we have OH functional group, that is alcohol functional group, whereas in the second case we have the the aldehyde functional group. Next type of isomerism is metamerism. So metamers also having same molecular formula, but they have different alkyl groups on either side of the functional group. So we have two examples. First one is diethyl ether, second one is methyl N-propyl ether. So in both the cases, this is the functional group. So in the first case, one side the functional group is attached with the alkyl chain having 2 carbon atoms, and another side it is attached with the alkyl chain with 2 carbon atoms. Whereas in the second case, methyl N-propyl ether, the functional group of oxygen, ether functional group is attached at one side with methyl functional group, whereas on the other side it is attached with alkyl chain having 3 carbon atoms. So these two molecules having same molecular formula, but they differ only in terms of the functional groups attached, the alkyl groups attached on either side of the functional group. Next type of isomers are called as stereoisomers. They have same molecular formula, same connectivity, different in their structure. They have same connectivity pattern, but the only difference is the spatial orientation. So how it is located in the space. So these molecules having or exhibiting difference only in terms of different spatial orientation. Stereoisomers is also classified into two important types. One is geometrical isomers, another is optical isomers. So what is geometrical isomers? They differ only in the spatial orientation of the groups attached to a double bond. So this is very important. So this type of isomers are observed only in the molecules having a double bond. The geometrical isomers also classified into two types. One is cis isomer, another one is trans isomer. So example, we have two examples. One is cis 2-butene, another one is trans 2-butene. So in the first case, we have a carbon double bond system, and it is attached with similar methyl group on either side. On the other side we have hydrogen group. So these two similar groups are attached at the same side of the double bond, whereas in the second case the similar groups are attached at the opposite sides of the double bond. So for more videos like this, kindly subscribe to our channel. Kindly click the bell icon for more notifications. Kindly share with your friends and comment in the comment section. Thank you very much.